So I've taken the constraints and moved them down to this area, and if you don't remember, if you don't see how I came up with these constraints, these three constraints right here, go review the last video. And let's go. Let's figure out this. Let's figure out how to maximize profit. Let's look at this first constraint right here. Let me do that in red. Put a red pointer somehow. Put a red pointer at that. So we know that 10 times the tomato sauces plus 5 times the salsas is less than or equal to 180. Now, the scale on our axes is always going to be an issue. So we need to be flexible and be ready to just reverse our scale or change it around. But when we graph this first linear inequality, let's just think about some some intercepts. So I am going to make, just because this t greater than or equal to 3s, this makes me think that t should be on the y-axis. And if you do it on the if you make t on the x-axis, the problem will still work out fine. So let me put t on the y-axis and s on the x-axis. And so this first constraint right here, we have 10. No, I want to do this in red. 10t plus 5s is less than or equal to 180. So what are the vertical intercept right here? So this would be, sorry, s would be equal to 0 because we're on this axis. T is equal to 180, or 10t is equal to 180, or t is equal to 18. So we're right there. And so let me write that. And what about when t is equal to 0? So we're on the s-axis. We see 5s is less than or equal to 180, or s is less than or equal to, well, 5 goes into 18 3 times, leaves 3, 30. So we have 36, so we're out here at 36. So let me put this point up here too. So this is 18. So we're looking at a straight line. Oh, that's terrible. Straight line going down like that. That's the best I'm going to do right now. So that's this constraint, and we're looking at less than or equal to 180, and the test point 0 would satisfy this. So we're thinking about shading down like this, but we're not going to shade yet. We're just going to know that in the back of our minds we're shading that way because we have a couple more constraints to satisfy. So let me get rid of this. So we're done with the first constraint. Let's go after the second constraint. So, whoops, I'm going to keep my color. So look at this constraint. So we have t plus a quarter s is less than or equal to 15. So what does that look like? T plus 1/4 s is less than or equal to 15. Well, again, at s equals 0, we're on the vertical axis. So this is 0. So t is equal to t is less than or equal to 15. So we're right there. And so what about when t is equal to 0? So we're on the s-axis. So let's look at that. 1/4 s equals 15. That's s equals 4 times 15 is 60. So we're way out here to the side. So let me just draw a line like that. It doesn't. We're way over here. But what about this point right there? So we need to find out what that point is. And we will do that by setting these two lines, the red line and the yellow line, equal to each. Or I'm sorry, we'll see what point satisfies both of those equations. So I'm just going to do this in let's just do that in blue. So 10t plus 5s equals 180, and t plus 1/4 s equals 15. Again, all we're doing right now is we're trying to find that point right there. What t and s satisfies that point. We already know we're shading down here, but again, we still have another thing here. So let's why don't we multiply everything by 4 on the second equation, and that will give us a new second equation, 4t plus s is equal to 60. Now let's do, let's think about what's the best way to combine the top equation and the bottom equation there, because all we did was take the second equation and put it in a slightly different form. And I kind of like the top minus 5 times the bottom, right? Because this is a 5, by the way. So let's do that. Minus 5 times this bottom equation. So we have 10 minus 5 times 4 is 20, so that's minus negative 10t. 5 minus a 5s is 0 by design. That's what we kind of thought about. 5 minus 5 times 60, that's 5 times 60 is 300, so we're subtracting 300, that's a negative 120, so you can see t is equal to 12. So we have t is equal to 12 right there. That's that point. And what is s equal to? We can go right back to this right here and put in t is equal to 12. So we have 48 plus s is equal to 60. And lo and behold, s is also equal to 12. So that's the intersection. So right there. What about this guy now? And I'm afraid I'm running out of time. Let's do this in blue. T is greater than or equal to 3s. Well, now we're talking about a line, and how does this line go? Well, it's steeper than an equation of t is equal to 3s is steeper than an equation of slope 1, right? And the slope 1 would go through 12, 12. So it would go straight up like this, and where would it intersect? Right here, right? And we're also thinking about shading. We're shading above, right? We're shading above. We also know we're shading below this yellow line, and we're shading below this red line. So this red line doesn't even enter into our constraint. So we're right here. So what is this area right? What is that point right there? That's where we intersect with the yellow line. So let's do that one real quick. Where does that intersect? So we have, oh, let me just erase this. As best I can. It's just like a regular blackboard, isn't it? So we're looking where yellow and dark blue intersect. So that's t equals 3s and t plus 1/4 s equals 15. So substitution, right? Looks pretty straightforward. Let's put 3s in for t. 3s plus 1/4 s is equal to 15. 3 is the same. This number 3 is the same as 12 quarters. So we have 13 quarters. S is equal to 15, or 13s is equal to 60, right? Just multiplying both sides by 4, or s is equal to 60 over 13, and this is 4, a little bit more than 4, so it's 4 something, 4 point, well, I guess we could do it the long way. Let's do 60 divided by 13, 4.6, okay. 4.6, so we have 4.6 is s. And what is t? Well, we can put it right into here. So t is equal to 3 times 4.6, and that is 13.8. So what is the dealio now? So that right here, that point right there is 4.6, 13.8. Well, this is sort of a critical point, and when we look at our profit function, we know we can't have this fraction, so we need to think about moving this way or this way on this line. And let me, in the next video, I'll talk about that, and I'll just wrap things up.